wanted to work through an example that involves reflection of plane mirrors. This is an example where we're going to find the images of an object in plane mirrors, and we're going to consider both a single reflection of a plane mirror and multiple reflections of a plane mirror to figure out all the images of the object. So in this question, we're told that we got two mirrors and they're placed or located at 90 degrees to one another. So downstairs here, I've sketched the two mirrors. I just called M1 first mirror, M2 the second mirror. There's a 90-degree angle between these two mirrors. We're told that we stand an equal distance from the two mirrors. So here you're standing or I'm standing, and I'm an equal distance from the vertical mirror, either on the right here, and the lower mirror below here. The question is, determine the location and the number of images of you or me in this arrangement of mirrors. So in solving this problem, there's a couple of images that I think are obvious, and they're based on a single reflection. And then there's a second image that is non-obvious, that's based on two reflections. So let's try and work through this. So one image that's obvious is due to a single reflection of this vertical mirror. So light travels from the left-hand side towards the right-hand side, strikes the mirror, bounces off the mirror, reflects off the mirror, back to the observer. This part here. The image that is formed by light first traveling to the right and then traveling to the left, back to the observer, is an image that is a virtual image. It's located at a distance behind the mirror that the object was in front of the mirror. It has a magnification of 1. And I'm going to call that image number 1. The second obvious image is one where the light travels vertically downwards towards the bottom mirror, and it will reflect off the bottom mirror, bounce off the bottom mirror, head back up to the observer, and we'll see another virtual image that is behind the lower mirror. It's a distance behind the mirror corresponding to the object's distance in front of the mirror. And again, it has a magnification of 1. So I'm going to call that image number 2. So that's two single reflections, two single images. But there's actually a third image. So the third image in this situation is created by two reflections. So that's a reflection of, say, the vertical mirror, and then a reflection of the horizontal mirror, or vice versa. It's also created by a reflection of the horizontal mirror, then a reflection of the vertical mirror. One way of thinking about this third image is to think of it as an image that's caused by the second mirror, the horizontal mirror, of an object that is I1, the image made by the first mirror. Or vice versa. The other way of thinking of this third image is that it's an image created by the first mirror, where the object is the image I2 that was created by the second mirror. So let me draw these cases. So let's start with a case where the second reflection is in mirror number 2. And it's a reflection in which the object is actually image number 1. So in this case, the light is appearing to come from image number 1, striking this bottom right-hand corner of mirror number 2, undergoing reflection, where the angle of reflection equals the angle of incidence, and traveling up to the observer, to you or I. So we see in this case a image that is the same distance behind the mirror that the object was behind the mirror. We just extrapolate it straight back. And so that image is located over here. I'm going to call that I3. A second way that you could imagine constructing this image is actually by the second reflection being in mirror number 1. In this case, it's the image of I2, I2 being an object that is reflected in the vertical mirror and seen by you or I, the observer. So in this case, I would be drawing or imagining a ray coming from I2, striking the bottom corner of the vertical mirror, undergoing reflection. According to the law of reflection, the reflected angle equals the incident angle, and it's reflected up and towards the left into the eye of the observer. So the observer then says, oh, I'm seeing a image. That image is the same distance behind the mirror as the object, which was I2, was in front of the mirror, but it's in a straight line back. And so that image is also located over here at I3. And so we discover that in this arrangement of two perpendicular mirrors, we not only have the obvious images I1 and I2 by a single reflection, but we have a third image that's created by two reflections. You could think of the light heading towards the corner, bouncing off the top, the vertical mirror, striking the bottom mirror, and then going back to the eye, or vice versa, the light going down towards the horizontal mirror, bouncing off the horizontal mirror, hitting the vertical mirror, and going back to the eye. That image is formed over here on the far bottom right, and that's the third image. Anyway, that's an example of images formed by reflection. It's an example of the image being the equal distance behind the mirror that the object was in front of the mirror. It's an example of the law of reflection, that the incident angle is equal to the reflected angle. And it's an example of the fact that with multiple mirrors, you can get multiple reflections and see multiple copies of an object in your mirrors.